Radical Dude here, and today we're going to be talking about imaginary numbers. Well, first of all, to see how these started, let's solve that quadratic. Nice and simple, right? There's a bunch of ways to do this. You can factor this as two binomials. You can use the quadratic formula. You can add 1 to both sides. I got x squared equals 1. I take the square root, and this comes out to positive and negative 1. Why is that? Very simple, because 1, if I put in here, 1 times 1 is 1, and negative 1 times negative 1 is 1. There you have it. Is that coming out clear? Oh, it's a little bit low. But what happens if I solve this quadratic? Well, now I take away 1. I have x squared equals negative 1. I take the square root of both sides, and I can't figure it out. Because what times itself is negative 1? Well, if I write 1 times 1, I already said that's positive 1. And if I write negative 1 times negative 1, that's positive 1. And if I make this a positive and a negative, then it doesn't hold for the square root because the number has to be the same. You can't use a positive and a negative. So what happened is in this guy named Bombelli, and I think I have a picture of him over here. Let's take a look real quickly at the Bombelli. That's the Bombelli, and he actually has the same forehead as my ex-wife. He came up with, let's call this imaginary. So that's what we're doing here. He said, let's make the I, and we're going to curve it so it stands out. So we have this. I equals the square root of negative 1. And the reason why they called it imaginary is because they didn't think that there were any applications for it. But today it is used in electricity, but I don't know very much how, with voltages, resistance, and things. But this is what it's used for. So I equals the square root of negative 1. And if I were to square this, let's take this I equals square root of negative 1. Let's play around. If I were to square this, well, then what happens? Well, here I have I squared, and here a square and a square root cancel, and I'm left with negative 1. And it continues. If I wanted to do I to the third, well, I to the third is I squared times I, right? I to the third is I squared times I. And I squared is negative 1, because we just discussed, this is very important. I squared is negative 1 times I is negative I. And then it will just repeat. Let's see what I to the 4 is. Well, I to the 4 is I squared to the square, which is negative 1 squared. 1. I to the 5th. The way I started doing them is, after a while, they'll be cyclical in multiples of 4. But what I do is just say, how many 2's go into the 5? So you're saying, how many I squares are there? There's 2, and there's 1 I left over. Right? That's the remainder. I could put a 1 here, because this is 4, and that's 1. That makes the 5. And then this becomes negative 1 squared times I. And anytime you have an even exponent of the negative, it becomes positive. So this is 1i. And it continues. So you have, if you give any number, just say 28, I to the 28, here's how I evaluate it. I say how many I squares go into 28, and it's 14. And then this is negative 1 to the 14th power, and that equals 1. If I were to do I to the 39, I would say how many I squares go into 39? And that's 19. That makes the 38 and a remainder of 1. 1 I. Well, this is negative 1 to the 19 times I. Anytime you have an odd number, think of it this way. If you're going out with couples and you're the odd one out, well, you're left out. So that becomes a negative experience. So this is negative 1i, or just negative I. That's it. And you can do it for any power you want with the base I. And that's all I'm going to show. Well, thank you very much. This has been Radical Dude, and I hope you learned something.